Okay, so for our final lesson of the year, it's lesson 11.8, and we're going to be adding and subtracting radicals. So again, our objective here is to simplify sums and differences of radicals. Now, what we're going to be doing here is I want you to sort of think about the radicals similar to variables. So for example, for number 1, what we could do is treat this 4 square root 7 plus 5 square root 7 sort of like a 4x plus a 5x, and think of the square root 7 as your x's. And all we're doing is adding the coefficients. So for example, when you were to add 4x plus 5x, you would get 9x. So the same thing is going to happen when we add and subtract radicals. In order to add them or subtract them, the radicals have to be the same, meaning you need to have the exact same number under the square root in order to add them, and then you only add the outside numbers. So notice in this first example, they both have the square root of 7, so then all I'm going to do is add 4 plus 5, and my answer here is 9 square root 7. I don't touch the radical, I just rewrite it. Now, if I were given a problem that said 2 square root 7 plus 5 square root 2, I couldn't do anything. That would be simplified because the number under the square roots are different. So if it says to simplify and the radicals are not the same, you just leave them apart. Now, if you can break it down like I just did in the last problem from 11.7, you're going to need to do that first. So always simplify your radicals. Make sure there's no perfect squares hiding in there. And then you'll go to see which ones you can add together. So in example 2, I see 2 radicals, or 2 numbers, or 2 terms that have the same number under the radical. So notice I've got a square root of 6 here and a square root of 6 here. There is no other term that has the square root of 13, so that term I'm leaving alone. But these 2, I'm able to add those numbers outside of the square root. So again, I would pretend like this isn't here, and then I would add 3 plus 5, and then my answer would be 8 square root 6, and then I just rewrite minus 2 square root 13. So there was nothing to add to that square root 13. Yeah, good? All right, next, again, sometimes we're going to have to simplify the radicals before we can add and subtract. Now, a lot of times when you're doing the homework, the ones that can't be simplified, that should be a clue of probably what you're going to break the other ones into. So, for example 3, the first one, 7 square root 3, I can't simplify. 3 is prime, I'm going to leave that one alone. Now, the next one, the 4 square root 6, yes, I could factor 6 into 2 times 3, but that doesn't help me. 6 can't be broken down any further. There are no perfect squares in there. So I'm going to rewrite that one also. Now, the 48, on the other hand, there is a perfect square hiding in there, and I can simplify the square root of 48. And I'm going to go ahead and do that. Now, chances are, I bet you one of my factors is either going to be a 3 or a 6 once I simplify this. So let's go ahead and break this down, and let's see what 48 is going to simplify to. Now remember, this term also has a 2 out front. So I'll go ahead and I'm just going to keep it there and bring it down. So I'm going to break my 48 into, I could do a number of different ways to do this. 2 times 24, 3 times 16. That would be the fastest for me. But I'll go ahead and do the common one that most students are going to do, is 6 times 8. So if I simplify that, now right now I'm looking, oh wait, square root of 6 was one of my answers over here that I already have in my problem. So chances are maybe that's what's going to be left behind. But let's see what happens. Maybe not. So break down the 2 and the 2 times 3, 2 times 4. Now remember, these are all still under square roots. This 2 is not. And then again, I can keep breaking it down. And then the 4 becomes 2 times 2. So now I'm going to go back and look for pairs. I've got a pair of 2's right here and here. So that'll bring out a 2. I've got another pair of 2's. So another 2 is going to come out. And then I have the radical 3 left behind. So for my 48, I can go ahead and multiply this thing back. And 2 times 2 is 4, times 2 is 8, square root 3. So now I'm going to replace my 2 times square root 48, this term right here. And I'm going to put in there plus 8 square root 3. Now I have to do the same thing for the 54. So whatever I get here, it'll be a minus. So let's do 6 square root 54. 6 is already out. The 54, I'm going to break this into 9 times 6. Now, if you realize 9 is a perfect square, you could square root it right now instead of going all the way down to pairs. But I'll go ahead and break it down. 3 times 3. And then 2 times 3. Pair of 3's. Nothing else pairs up. So 6 is out. The pair of 3's, one of them comes out. And then I'm going to multiply the 2 times 3 back. So I get 18 square root 6. So that's what goes here. Now I have everything simplified. Now I can go back and add and subtract. So again, I can only add and subtract the same radicals. So I have a 7 times the square root of 3 that I can group with the positive 8 square root 3. Once I add those two, I'm only adding the coefficients outside. So I would get 15 square root 3. Then I'm going to go back and I'm going to add negative 4 square root 6 minus 18. So I take the sign that's directly in front, and that's going to give me negative 22 square root 6. Now I'm done. I could factor that 6 into 2 times 3, but that doesn't help me because I need to make a pair in order to get rid of things. So when we simplify the sum and differences of square root radicals, we're going to first simplify all the square roots, and then we're going to go ahead and add and subtract the radicals with the like radicands, or the terms that have the same number under the radical symbol. Do a few more examples before I give you time to start your homework. So for example, in these oral exercises, number 1, notice they're already giving us the same numbers under the square root. So all I would have to do is add the 2 numbers that are outside. So 3 plus 2 gives me 5. And then the square root of 5 is underneath. Same thing on number 4. Notice they all have the square root of 7. So all I have to do is add 6 plus 9 plus 2. And that would give me 17 square root 7. The same thing applies for the subtraction. So on number 7, all you're going to do is 12 minus 7 and get 5 and the square root of 3. Now, number 10, notice there are no like numbers or no like radicands, so I need to break down that 27. So on number 10, you would factor this. You could make it 9 times 3. And again, if at this point you realize that 9 is a perfect square, 27 simplifies to 3 square root 3. And now I can subtract the square root 3. Now, if you have a radical that doesn't have a number in front, assume that there's a 1 out front. So now when I go to subtract this, I'm doing 3 minus 1, and I get 2 square root 3. So if you have a problem that doesn't have a number out front, always assume that there's a 1 out front. So again, you need to simplify the radical first, and then look for like radicals, or the like radicands. And then those are the ones that you'll combine. Use the sign that's in front. If it looks like it's a subtraction sign, then that number out front is negative. So you do have homework. Your homework for 11-8 is 1 through 18 all. Tomorrow we will go over these problems, and then we will review for your last test after we go over the homework. Remember, when you're simplifying these, you can't leave a square root in the denominator. It doesn't look like I've given you any of those for homework. It looks like they're all right up here, so you should be fine. Just know that down here, they were finding a common denominator, but you don't have to do that part. Okay, so your homework is 1 through 18 all. You do have a few minutes where you can get started on this. And if you get stuck on anything or you need help, let me know. Again, the first few already have like radicands, so you're just adding those coefficients. But once you hit number 4, it looks like, that's when you're going to have to simplify first and then combine them. Okay, that is it.